Hello. So once again, this video is sponsored by Autodesk, and I thought what I'd do is play around with some scattering stuff. So first of all, what I'm going to do on this mesh is paint a vertex map, and so I'll flood it with black and I'll paint some red like that, just something quite simple. Okay, so that's first of all, and I will hang on a minute. Okay, no, that's fine. So that map is on there, and it's called color set 1. So let's rename that to path, just because that's going to be the this little path bit. And I've got some grass here and a stone. I mean, this is quite simple. I've just got one bit of grass and one stone under there. So they're both at the origin. And I'm going to make a tree. I'm going to bring in that ground. And the first thing I'm going to do, I'll get rid of that, is scatter some points. So scatter points. Geometry is the ground. So we're going to scatter points on there. And the points are going to be, if I do that, you'll see them there as little dots. This scatter points thing will tell you the amount and stuff like that. I haven't gone through this in detail. There's a mask. I don't know quite how do you feed that property in. I don't know. Anyway, I'm not going to use that for the moment. What I'm going to do is I'm going to make the amount higher. So let's take that up to, like, I don't know, 3000. Okay. And it has this location thing here coming out here. So if we get a sample location, or sample property, which you use with locations, we want a sample property on the mesh, not on the points. The locations go into there. The default I want to look for is a MathFloat 4, which is that color map type, which is an RGBA, so 4 values. And out of there, oh no, we need to type that in, so we called it path, and we're getting a float 4 out of here. So if I get a float 4, no, scalar to vector 4, sorry, the other way around. So vector 4 to scalar, that means that's got 4 values in, and we want to use the R, which would be the X, but I mean it's the first one, RGBA. So then we'll say if that X value is less than, so let's get a less than, or less. If it's less than, say, 0.5, then we will delete one of these points. So delete by Boolean array. So this is a Boolean array. This is an array, a list of yes or no's. And these are the points coming in here. And if we do the out geometry there, we should, if this works, just have the ones on the path. No, because of some reason. So let's have a look. Let's value type there, MathFloat 4. Property is path. Let me just check that property is actually called path. So let's have a look on here and make sure. So actual add a watch point. Property. So we've got all these properties here. It is called path. It's a MathFloat 4. So sample property, path, 4 values, MathFloat 4, or it's a vector 4. It's the same thing. Vector 4 to scalar. The R, if it's less than 0.5. Then we get yes or no's. Delete point by bool array. Okay, I don't know what I'm doing wrong. Let's try and see if this value is... Okay. It's interesting. Okay, I presume this goes from 0... Well, that sort of works, but I don't know why 0.5 wouldn't work. Anyway, I don't understand what the range of that is, but it's kind of doing what I want. I just got the value wrong. So we want to put stones on this path. So let's get some stones now, and I'll get a stone. And what we want to do is we want to replicate this stone wherever there's a point. And to do that, we'll do a for each. So this is a loop, and we're going to loop through each of these points and put a stone there. So we want to. So that's the. That's the point cloud, and this is the mesh. So let's go into that. Double click on that. We want to iterate over the point cloud and do stuff to the mesh each time. So the point cloud that we're iterating over, we want to get, in fact, I'll tell you what, we don't want to do it iterate over just the point cloud, we want to iterate over the points in the point cloud, so we need to get point positions. Get point position, not velocity, get point position, stick that in there, and the point position we want to go into there, and make that sure that's still iteration target. True, so that's good. We don't need max iterations because we want to iterate through all of them. At the moment that's just set to 10, so we can delete that. And for each of these points we want to do this. We want to get the mesh's point position, so we'll get the point position of the mesh. Now this is the stone mesh, and we want to add this to the point cloud position, which will then, because at the moment this is in the origin, so if we add the position of these to the stone which is at the origin, we'll end up with a stone being drawn or being replicated at each of those points. Right, so let's do that. So add that point position to that, and then we'll set the point positions on the mesh. So set point position like that on the mesh, and now out of here, because this is iterating over each point cloud, each point on the point cloud, we're going to end up with an array outside here of meshes here, or not an array of, well, basically, yeah, like an array of different stones. So if I plug that into there, you'll see them all there, like that. So let's just unselect that there, and you can see them all there on the path. But at the moment they're all the same size, which doesn't look great, so let's go back in there and do something to them each time. So remember, this inside here is as if it's just doing it one time, but it's doing it over and over and again, iterating over all the points in the point cloud, and that's why we're ending up with loads of them. So each time we could say make it a random size. So these point positions, now remember the point position here, before we added it to there, is just as it was at the origin. So if we just multiplied the point position, basically this will just shrink it down. So if I do that, I then go that into the point position, and then I add a value here, which actually we don't need as a float. We can just do this as a scalar, because it will just apply it to all of the three values. So if there it's at 0. If I do it at 0.1, you'll see they come in, but they're small, and then at 0.5 they'll be a bit bigger, and 2 they'll be really big. So what we want to do is make this a random value instead of instead of, you know, just a value the same each time. So what we want to do is get a random value, and we'll do the minimum at, say, 0.3 and the maximum at, say, 1.5. 1.5. Now if I plug that in at the moment into that output, now that is a random value, but it's the same random value because of the way that this stuff works. It's the same random value each time, you know, for each stone. We don't want to do that, and to change it, what we do is the current index, if we plug that into there, that means that each time this runs through this loop, that current index will change, and it changes the random value. It works a little bit like the seed. I'm not going to go into a big explanation of that, but the seed, again, if I change the seed, it will sort of change all the random values. Sorry. There, you see they changed, so I didn't need to hit enter there. So now they're all different sizes, so that's kind of good. But we could also rotate them around as well, which gets a little bit more complicated. I mean, it's the same type of thing, but you know, we need to rotate this vector. So let's just spread this out a little bit. So here we need to rotate this vector. So let's first of all go rotate by quaternion. Vector, rotated vector, they're going to disappear when I do this because there's no quaternion yet. We'll get an axis and angle to quaternion. So we're going to make a quaternion out of an axis and an angle. That has a radians input. I'm going to change that to degrees, so I'll go degrees to radians because I don't like radians. Well, it's not that I've got nothing against them, I just don't really, you know, don't understand them. Then we're going to need another random value, so I'll copy that and paste that in. Again, we're going to need this current index, and we'll plug that into the amount of degrees it's going to be rotated by each time, and it's going to be a random amount between the minimum and the max. On this one, I want the minimum to be 0 and the max to be 360. And also, we didn't put an axis in here yet, but let's do that on the y-axis. So that's just going to spin them around randomly. If I look from above, you can see that they're all sort of spun around. Now the reason they're looking all weird like that is because of the point normal thing. You have to update the point normals at the end on this geometry because otherwise they're not, you know, well, you just need to do it. Update mesh normal, sorry, there you go. If I do that, they'll look a lot more natural. There you go. So I've got a bunch of stones in there. You know, so that's kind of like a half decent start. Probably want more of them, to be honest, so I'll go back to the scatter points and say 8,000. Oops, not 800, 8,000. Okay, so that's that. Don't need to see that. So that whole thing I could sort of package up into a compound if I wanted. Control G. And then if I want grass, I'll duplicate that. And we'll do grass for this one. So let's get the grass, although we need to edit and make some changes in this one. Now, again, as I like to say, you'd make these compounds to do all these different tricks, and then you just use the compounds. You wouldn't, you know, you wouldn't be expected to do this from scratch every time. This is a tutorial on the inner workings of Bifrost. So you might make a compound that has everything exposed, like here, for, you know, rotation, size, different minimum, maximum amounts on the, you know, on the size and on the amount of rotation and all that sort of thing. But this one here, I'm going to do for the grass. Now that's going to draw it, because this is identical, it's just going to draw the grass inside there. It's going to do exactly the same thing for the grass that it did for the stones. But I want this to be different. And on this one, what I'm going to do, instead of using that path thing, so sampling property and getting the path, I'm going to sample the property and get the point normal instead. So I'll get rid of all this stuff. And here, oh no, looks like it might have crashed. Oh no, it hasn't. It isn't just not deleting any of them. That's okay. I'll put that amount down to like 800 while I'm working. These aren't instances at the moment. These are just, this is just drawn geometry. So I need to sample the property on the stone. So on that. Sorry, not on the stone shape, on the mesh that's coming in, which is this mesh, the top one, which is the ground shape. And what I want to do is I want to delete them when they're not, when the ground isn't flat, like as if it's not, where it's not horizontal. I'll delete them and I'll keep them. I mean, where it is horizontal, I'll keep them, and where it's not horizontal, I'll delete them. Did I say that right? It doesn't matter. Well, you get it when I do it. So sample property, we want to get the point normal here. So point normal, and that default is not a float 4, it's just a float 3. It's just like an X, Y, Z. So this out of here is bringing all the point normals for each for each of these points that were scattered around. It's now getting a location on the geometry beneath it, this ground, and finding the normal. And so what we want to do is compare that angle to, so angle between the normal and just pointing it straight up on the Y. So 0, 1, 0. And we want to say if those degrees are less than or greater than, sort of say, so if the degrees are greater than something like 20, then we'll use this output, which is a Boolean, so it's a bunch of yes or no's, and we can use that into a delete point by Boolean array. So we'll do that, and we want to delete these points, and we'll plug those in there. So yeah, okay, so that's great, that's working. So basically now where the ground is flat, they're not being deleted, and where the ground isn't flat, you know, on sides of hills and stuff like that, they aren't being deleted. Now I don't know how much further to go with this, because this is, okay, well let's go on a little bit longer. Right, so into this for each thing is where we're doing that rotational thing and stuff like that. Let me just do the layout here, auto layout selected, so that's just going to get that looking a bit neater. Don't know if I've showed that before, but that's quite a handy, oh yeah, it's quite a handy thing to use for just sort of neatening up this graph. So we've got this axis and random amounts of rotation, so that's all good. The size here, we could change the size from say 0.2 to 1, which will make them all generally a little bit smaller. And if we look from above, they're all randomly rotated, but they're all pointing vertically upwards. So if we wanted to make them so they're not pointing vertically upwards, because basically they're rotating around this axis, we'd need to change this axis. So to do that, this is slightly more involved. I've got a tool to do it, but I'm going to do it from scratch. We're going to need to get a random value. We're going to need to put that random value into the axis. No, sorry, that's not right. It is right, but we need to make sure that coming out of here is a vector 3. So I think if I plug it that way, it might work. No, it's not. Let's get another one from scratch and plug that in. Okay. I think maybe if I make these vectors, let's get a value. Now it's coming out with just a scalar. I think I might need to make this the input of this a vector 3 in the first place, so it adapts to being a vector 3. if I do the minimum as that, and the maximum, I'll change those values in a minute. Yeah, okay, so now it's changed to the same color as this, so now it's vector 3. So we've got now a minimum of, say, what we're going to do is make a minimum of minus a certain value and then a maximum of plus that value. And then we're going to add that to the axis that we want. So basically this random value will deviate away from this. So let's say this is that value, and we'll add that to this random value here. So, you know, we're still keeping it as 1, you know, on the y, but this random value is going to be added to that, sort of making it deviate away per thing. We're going to also need to use this current index thing going in there, and we want to change this. Now if I do this, say like now, from -1, -1, that's going to be a bit of a palaver doing all of that. We don't want to change all of those values, we just want a single value here. So what I'm going to do is I'm going to get a value, and I'll say that we want that value to be sort of 0.5, and this is the amount that it's going to deviate away from. We're going to need to feed that into, say this is minus 0.5, this is plus 0.5. So we can't just feed that as a single value, we can't just feed that into a vector, so we need to get a scalar to vector 3 and plug that into all of those, and that should do for that one, for the maximum amount. But for the minimal amount, we'll need to copy that and put that in there. But what we need to do between here and there is multiply it by -1. So multiply that value, just plug that back in there, by -1. So create a value node and make this -1. Okay, and now this value here we can use to, you know, if I make that 0, they're all going to be pointing straight up, and if I make that sort of 0.2, they'll all start, you know, the axis on which they're rotating will be changed, so it will, you know, there'll be more chaotic, which is kind of what we want. 0.5. Again, all of these things would be, you know, you wouldn't work like this. You would have this thing here as a compound that you know, that you would call this compound, you know, rotate random axis or something like that. Unfortunately, at the moment, you know, it does have some of these type of things in Bifrost, but I think it needs a lot more of these. One good thing about ICE is it has a really good comprehensive set of these nodes, which makes it a lot easier if I'm doing a tutorial for people to follow it, rather than having to make all of these. So this gives the impression that why would you want to do this if you're scattering stuff? But you wouldn't. All of these would be nodes which you built, or, you know, are there already for, you know, for doing this stuff. But I'm just going through it as a tutorial thing. So, okay. I'm not going to go on much further than this. Obviously this is quite simple, because I'm building the actual scattering tools themselves rather than just, you know, just using them, as it were. So we're scattering a bunch of stone shapes on the path. We're scattering some grass on the ground. We haven't got enough grass. Let's get more of that. So we'll go back into there. Let's do sort of 7,000 or something. That's going to be a lot. I have to wait a while for that to update. Okay, but hopefully that's been useful to sort of go through some of those processes. Really, with the great thing about Bifrost, if you do use it for scattering, is you can make nodes that do anything. I mean, anything you can think of. You could have grass that sort of leans towards the tree, or, you know, just leans towards the slopes. Things that get bigger in certain areas. You could sort of work out the angle of slopes and make pools of rocks that sort of collect at the bottom. It's just basically down to your imagination. What I've done is super simple, but hopefully it might show the starting potential of using Bifrost for that type of thing. Anyway, this video is getting long, so thank you very much. That'll be the end of this one, and post another one soon. Cheers, bye.